Hello, this is Fred again on location in Colombia. You know, technically I'm not a botanist or a molecular biologist, but I do have a bachelor's degree in science, political science. But today I want to talk about carbon removal and my favorite method of carbon removal, which is called photosynthesis. And that's the process by which plants like these, we've got some corn here, we've got some coffee, we've got some various trees, fruit trees, some bamboo back there on the hillsides, and there's some cassava, also known as yucca, growing around here, lots of plantain. Lots of plants, as they grow, they photosynthesize, they take sunlight and convert it into food, into sugar, to keep the plants growing. As they do that, they participate in the carbon cycle, which is the most important part that I want to talk about right now, which is the process of absorbing CO2 out of the atmosphere, carbon dioxide. And carbon dioxide is basically carbon and oxygen. The plant takes that, separates out the carbon, and releases oxygen. So in that way, plants generate oxygen for our atmosphere. Oxygen is very important for humans like you and me to inhale and keep our bodies happy, healthy, and living. The carbon, which is separated from the oxygen, the carbon gets stored in the biomass of the plants. And in some cases, the plant might dry out, decompose, and then the carbon is released back into the atmosphere. In other cases, the carbon is stored for longer term, like in trees or in bamboo. In coffee, for example, they'll cut back the coffee plant. This one was cut back recently. You can see on the stump there. And then now it's growing back. But that part that was cut off, that was loaded with carbon. And if it's left to sit around, the carbon's going to be released. It's going to decay, decompose. The carbon's going to release back into the atmosphere. You may have heard something about carbon levels in the atmosphere. It's a leading cause of climate change and a great concern for people like me. If we take steps to prevent that biomass from decaying and decomposing and releasing CO2, we can stabilize, lock that carbon into a permanent state. And the way to do that is by making biochar. And that is what we're here to do this week. So in this case, they're using the offcuts of the coffee prunings that I just pointed out. Behind me is our team of trainers and kiln operators gathered around the Kontiki kiln over there, where they're going to be making biochar from the coffee prunings. Lots of wood. There's some piled up right here. It's a regular activity that they do on the coffee plantation to prune and cut back the coffee. So all that wood back there, they throw it into a big kiln. They cook it at very high temperatures, between 550 degrees to about 800 degrees Celsius. And at those high temperatures, all the impurities burn off. The carbon is concentrated, stabilized. So you end up with, in the case of coffee, you end up with a charcoal-like product that's about 75-80% carbon. So that carbon is being kept from going into the atmosphere, and instead of releasing it into the atmosphere, contributing to climate change, the carbon is buried into the soil as a soil additive, adding important nutrients into the soil. The biochar is super porous, which helps with soil retention and nutrient retention, and also attracts lots of microorganisms to fill in those little nooks and crannies of the porous surface area of the biochar. So in that way, we're helping to combat global warming. We're helping to regenerate degraded landscapes. We're helping farmers to get better yields out of their crops and use less chemical commercial fertilizer. So it's a win-win-win all the way around. And after all that, we're able to generate carbon credits to help finance the project, which is very important for the rural farmers here in Colombia to get a little extra cash flow to help them make time to participate in this project of producing biochar. That's what we do here, and things are going really well. Stay tuned for more videos.